that better, Peggy?
Much better, thank you.
All right, so this is the slide I was talking about, Atlantis at a glance. 10x performance, 10x capacity, all flash performance at half the cost of SAN. Then I went on to this slide where I explained how storage is growing at a very fast pace. On the left is the growth of physical servers plotted against the growth of virtual machines. So you can see back in 2006, 2007, the growth of physical servers actually slowed down significantly, but the growth of virtual machines is going much faster and faster. And then here you can see the growth of storage in terms of capacity, the bar graph, and in terms of revenue on the right. Like I said, so 40% year-over-year growth in terms of storage capacity. This means really that every 2 years you need double the storage infrastructure. Okay. So at Atlantis, we're all about optimizing storage both in terms of performance as well as capacity, right? So let me show you what it means to basically introduce an all-flash hyper-converged solution together with Citrix, right? Because we are a 100% software solution, and because we work with any hardware, we make it very easy for you to deploy a storage solution, a hyper-converged storage solution, through automated deployment, through automated management. We can provide you a lower cost per gigabyte. In most cases, the savings is somewhere between 50 and 80% on a per gigabyte cost. And this is compared to other hyper-converged appliances. I'm not even comparing about enterprise-level SAN, enterprise-level NAS. We'll give you more than 10x the I/O performance than competitors. And we are very flexible in hardware options. We can install our software in a hyper-converged fashion in rack servers. We can do it in the high-density 2U appliances that are becoming very popular, where there's 4 nodes in a 2U appliance. Or we can even do it with blade servers, where we're putting a little bit of flash in each blade server and basically pulling that together to create a completely enterprise-level storage system. Let me go into those points in a little bit more detail. USX is very easy to deploy. So starting with USX 2.2, which is going to be released in just a few weeks, you can deploy our software both on VMware ESX as well as on Citrix XenServer. And you do that by first deploying our USX Manager, which is our management UI. And this is really the nexus of your storage management. You can automatically deploy the Atlantis components on the hypervisors to basically build an enterprise-class storage array out of local flash, out of local resources. I'll explain in a little bit more detail how that works from an architecture perspective. Right. Once the Atlantis components are installed, you can use the Atlantis storage to install your application virtual machines, whether this is VDI, whether these are regular server-based workloads. You install those on Atlantis USX. Very easy to deploy. It takes about 10-15 minutes to install our software and make the data stores or storage repositories ready for use by your applications. And once our software is installed, we can give you incredible storage performance. Using our all-flash hyper-converged architecture, we can build a solution where out of 4 servers, we can give you 3.3 million IOPS. And these are not the typical benchmark IOPS where it's completely read and completely serial. No, this is a real workload. This is a 50% read, 50% write workload, and 80% random. So very similar to, or very much emulating what a server application would throw at the system. And the latency is very low as well. At 3.3 million IOPS, we're giving you a 1.15 millisecond latency. This is unheard of in the industry. And all of this without any enterprise legacy SAN or NAS storage hardware. This is just using local resources. Our solution, because we are software, scales very well as well, right? We can deploy Atlantis on a single server. We can scale out by deploying Atlantis on many servers in your rack, whether that's blades or rack mounts or using these high density 2U servers. But we can also do a scale up, right? We can also add more storage into the servers and increasing your storage performance and your storage capacity in that way. And in that sense, it doesn't make a difference whether you extend it by flash or whether you put local spinning disks in those servers. We will use the flash to optimize the access to your capacity tier, which is comprised of spinning disks in your servers. So all of this, what does this mean for the graph that I showed you earlier? Right? If you look at if a company has 100 terabytes of storage today, if you plot it out over the next 10 years, it means that your storage consumption will be somewhere around 3 petabytes in about 10 years, right? If you deploy Atlantis USX in your data center, we basically, in year one, we reduce your storage capacity requirements by about 80% because of our inline deduplication and all kinds of storage optimization technologies that I'll talk about in a little bit. Right? So on year one, your 100 terabytes basically shrinks down to 20 terabytes. And that has dramatic impact on the growth of your storage from a capacity perspective. Right? So over 5 years, just by using Atlantis USX, just by using our software, we can save you about $1.3 million in storage spend over the next 5 years. If you extrapolate that over 10 years, we're looking at a total storage spend savings of about $7 million. And all of that, once again, is because your year one or your day zero storage capacity decrease is really what's driving this, right? By decreasing the initial amount, you're decreasing the growth over the next 5 years or 10 years. And we really see this happening in a few phases, right? Day one, you will use this to consolidate your existing SAN NAS. Right? You will be able to replace this existing SAN NAS as the maintenance cycle comes up. You will be able to replace this expensive SAN NAS with a complete hyper-converged solution using USX. You can start augmenting for those applications that need it. You can start augmenting all flash arrays because our deduplication technologies make all flash arrays affordable as well. And then in a few years, you will be able to migrate data into hybrid cloud as well. So you can leverage the cheap storage of hybrid clouds into your data center storage as well. So let's talk about it a little bit more in more detail about what is Atlantis USX. Right? Our software is comprised out of 3 or 4 layers. At the bottom, we have technology that basically allows us to pull together either local storage, and it doesn't matter if it's flash, spinning disk, or memory, together with shared storage. And once again, it doesn't matter if it's iSCSI, private channel, NFS. We can pull together all of these different classes of storage and use fast storage for increasing the performance and use the capacity tier to basically provide the capacity. On top of this pooling of storage, we have a very rich set of data services. Of course, number one, everything is built around data reduction. We have multiple patents around inline deduplication for application workloads. Right? And this is really the core of our IP. Any of our data service, any of our value prop is built around the notion that we're very good at inline deduplication. Right? So we do inline deduplication. Typically for most workloads, we take out 70, 80, in some cases 90 or 95% of the capacity through eliminating duplicate blocks. But we also use it to our advantage to speed up your applications. And we do that through I/O acceleration. So we have a very smart way of caching data that is used all the time in memory in a completely deduplicated way. So rather than caching the same block 100 times because there's 100 virtual machines that are using it, we're actually only caching it once. So we really make use of server memory or server flash to optimize the access to your data. We have data management services around as well, where we're basically providing you with very fast and very efficient ways of making snapshots or clones of your data. We can provision new virtual machines within 10 seconds, right? So it makes it very easy to quickly scale out your data center. We have data mobility services. We have what we call a teleport. Teleport is a service that kind of resembles storage vMotion, but it's on steroids. It is a completely dedupe-aware way of doing storage vMotion across data centers. So rather than copying full virtual machines or full data sets around from data center to data center, we actually calculate what the differences are between the data sets and only copying over those unique blocks. So rather than transferring a 200 gig virtual machine from data center to data center, with us, we'll only copy out a gig or two. So that opens up some really interesting use cases. We have security built in. So at the moment, we store data on disk at rest. We can apply security, we can apply things like encryption to that data. So anything that is on disk will be encrypted. And then we have a unified storage approach as well. Like I explained on the bottom, we can basically consume any kind of storage, but to the application, we can look like any kind of storage as well. So if you say you're using local storage on the front, and to the application, we can make that look like either NFS or iSCSI. So we do a lot of protocol translation as well. Then on top of that, we have a very rich management layer, right? Everything we do is policy-based storage management. So you tell USX what you need in terms of application performance, application availability, application capacity, and we will go out and we will provision storage using the storage you give to us at the bottom. We will pick the right pieces of storage to build a storage volume that has those characteristics that your application needs in terms of capacity, once again, in terms of performance, and in terms of availability. And all of this is exposed through a very rich REST API. Right? Anything you can do from our management UI, you can do through our REST API. Our management UI only communicates with our services through REST. So it's a fully implemented REST API. So this allows you to extend USX into any third party or any house-built management infrastructure as well. Right? So whether you have you've developed your own in-house development operations, whether you're using vVol or whether you're using cloud storage providers in the future, or things like SCOM or vCenter and so on, you can very easily build integration modules that use our APIs to augment your day-to-day workflow and your day-to-day management. So let's have a little bit more closer look at what this means for a hyper-converged architecture. What you see on the screen right here is an architecture, a 4-node architecture that is optimized for VDI together with Citrix XenDesktop. It's a complete Citrix stack. So we're using XenServer as the hypervisor, and we're using XenDesktop or XenApp as the broker or as the provisioning technology to provide you access to your data and to your virtual machines. We have 4 servers. Each server has 4 400 gig SSDs in it. Each server consists of 2 2680V2 Intel processors. There's 384 gigs of RAM in each of these servers. We're using XenServer 6.5 in this case because it's the latest and greatest, but USX completely supports XenServer 6.2 as well. And at a minimum, you will need 2 10 gigabit networking in each card. This is to guarantee that we can give you the throughput and the latency that we need. USX 2.2 is installed on all of these servers, and we've created what we call all flash volumes for the VDI or XenApp volumes. All flash means that we're leveraging the speed of the flash, but we're basically disabling our own caching layer because the flash will gives us enough raw IOPS already. We don't need to use extra memory to do a level of caching in front of that. We've configured the volumes so we can sustain any host failure without losing the availability of the volumes. We've configured it to be exported through NFS and 50 gigs of RAM for the volume VM. And this RAM we use to do things like inline deduplication, inline compression, and so on. Right. So there's 2 of these volumes on 2 hosts. We're splitting out 2 volumes to provide storage to the VDI virtual machines that are running on 2 hosts, and then the other one serves the storage to the other host. On each and every server, we have a little service VM, and the role of this service VM is to consume the local flash, pull that up, provide data integrity, data protection across all of the hosts in the pool. Think of it as a level of networking RAID, and then provide that storage, that pooled storage, to the volumes to basically provide back to the hypervisor and provide back to VDI virtual machines. So for SSDs, you need server, 400 gigs, and we were able to build 2 volumes that basically provide enough storage to run 500 VDI virtual machines on these 4 servers, or something like 1,000 XenApp users on these servers. If you look at it from a logical perspective, this is the picture, right? So coming from the bottom, once again, we have 4 servers with SSD. We have a service VM on each server, and once again, this is a very small VM, just 6 gigs of memory. We're using about one vCPU on each server. This is exporting the local storage, providing data protection across nodes, and exporting it to the USX volumes. There are going to be 2 USX volumes that are providing storage to the virtual machines. And then we have a third one that basically provides the HA failover capabilities in case one of the nodes fails where the USX volume VM is running. And then on top of that, we have all of the VDI virtual machines, right? And there is resiliency built in on each and every layer, right? If the host fails where a USX volume is running, we will automatically fill over those volume services, those data services, to the HA standby virtual machine over here. If a service VM fails, there is data protection across all of the service VMs. So the volumes don't even notice that the service VM is down, right? If a host fails, for us it's the same as if a service VM fails. We'll treat it the same way. There is protection across the servers. The volumes will not notice that a host is down. And even if one of the local flash devices is down, we have data protection at that level as well. So we will be able to sustain a SSD failure. You will be able to plug in a new SSD, and will automatically rebuild the data using that new SSD. Same thing happens if a server is failed permanently. You can basically provision a new physical server. You tell us, well, use this server to replace this field server. We will automatically rebuild the data resiliency across that server, so we will resync the data to that new server, and things can just continue very, very happily. So let's extend this a little bit more into what this means for a persistent VDI deployment. And this is the announcement we've done with Citrix, when was it, about a month ago. We announced, together with Citrix, we announced a complete Citrix stack using XenServer, using XenDesktop, and using our software to provide the storage for those, right? If you look at VDI in general, right, once again, VDI, you compare the performance and the price of VDI. Needs to be in line, needs to be cheaper than the cost of a traditional PC, right? If you would go to Fry's or to Best Buy or your favorite computer store, you can buy a new PC or a new laptop probably for somewhere around $400, $500, in some cases about $800 or $1,000, right? If you look at inside, what is the cost for your CPU, for your RAM, for your storage? CPU is relatively cheap, $200, RAM $80, right? Storage about $60. If you just have a a 7200 RPM SATA disk in there, that runs about $60. If you put an SSD in there, it's a little bit more, but the total capex that you spend on a traditional PC is somewhere between $500 and $1,000. Right? If you use a spinning disk in there, you get somewhere between 80 and 150 IOPS. Right? And this is important because your users are used to the performance that they're getting out of a laptop, that they're getting out of a PC. If you go to VDI, to build a traditional VDI desktop that has the same performance characteristics as your traditional PC or your traditional laptop, you're looking at a much higher price. And why is that? It's not because of CPU, because you're actually sharing CPUs in your server. It's not because of RAM, because once again, you're sharing RAM in your server. It is because of storage. Right? Traditional SAN storage is built for capacity. It's not built for performance. So to be able to purchase enough storage to give you that 80 to 150 IOPS per user, you're looking actually at a storage spend of about $1,000 per user. So very, very expensive to build a VDI desktop that has the same performance characteristics as a local PC. And Gartner completely agrees with that. Right? If you look at the total cost per VDI desktop, storage is about 60% of that cost. Gartner says, on average, across all VDI projects that we've looked at, the cost of storage is about $1,000. And of course, on top of that, you have your Microsoft licensing, you have your licensing of your broker. Cost of your server is only around $100. Right? Cost of a thin client is about $300. So storage is 40 to 60% of your VDI budget. If you build a hyper-converged VDI solution using Atlantis USX, you can save a lot of money, right? Because you're only using local flash, you're only using commodity servers, right? And using our software, you can build a very high-performance VDI solution using those much cheaper resources, right? So we basically provide you an integrated solution, very simple to deploy, right? You don't have to deal with SAN configuration, SAN zoning, setting up separate storage networks and so on. Very easy to deploy. Just install a bunch of servers, you install our software, and you're up and ready within a day to deploy, to get to your desktops, basically. We've done quite a bit of testing of these results over the last few months, right? Porting our software to XenServer was very easy, but we've done a lot of performance testing to make sure that the performance that we're seeing on XenServer is actually on par with vSphere. And actually it is. XenServer 6.5 made very good improvements in terms of storage performance, in terms of network throughput, and so on. It's a very nice platform. The graph I'm showing you on the screen right now is a Login VSI graph. Login VSI is a tool from one of our partners in Holland that is measuring user experience. And they do this by emulating VDI sessions. So they're actually logging into VDI sessions and emulating what a user would do in such sessions. And they're measuring the response time. So they do a little bit of typing, and they're measuring how long it takes before those characters actually come back. They will load videos, and they will look at frame rate. They will open documents, and they will see how long that takes. All in all, they're doing these measurements to see if a VDI environment can scale to what the vendor actually claims. So it measures memory throughput, it measures CPU, but it also measures storage, right? If your storage is undersized, opening up new files and doing typing and saving files and so on will take much longer than it would take on your laptop, right? So this is the graph that we've produced out of those 4 servers that I showed you earlier, right? So once again, 4 x86 nodes, 384 gigs of memory, and 2680 CPUs in there. Here you can see that at the first 50 users, our baseline is about 800 milliseconds. This is the aggregated response time across all of those operations. But the interesting thing to see is that as you put more users on this 4-node system, the response time actually stays quite a bit the same. Typically, login VSI traditionally says anything above 4,000 is not acceptable. If your aggregated response time is above 4 seconds, things are too bad. It's not usable. They've since revised it a little bit. Now they are measuring a baseline, which is the first 15 sessions, and then they do a calculation based on those first 15 sessions, what your threshold is. In this case, they say anything above 1,800 milliseconds is not acceptable anymore. But as you can see, our aggregate response time stays way, way below there. So your user experience is going to be excellent using this all-flash hyper-converged session. If you look at the bill of materials for this, I'm showing that on the screen right now. So we did this test using a super micro environments, but we have some sample bill of materials for other vendors as well. I'm getting there. But in this particular case, we were using the super micro. This is one of those 2U 4-node boxes. Like I said, we're using the 2680 CPUs in there. We had some DIMMs for the memory in there. We were using the SanDisk Cloud Speed 400 gig SSDs. And then we included our Atlantis USX licensing price. Right? The total bill of material cost for this setup was just shy of $90,000. If you amortize that over 500 desktops, we're looking at a hardware and storage cost of $179 per desktop. Right? So very, very cheap to provide a completely persistent desktop to your customers. Once again, if you compare that to more traditional ways or even more advanced ways like hyper-converged appliances, you can see how much money you can save using our solution. So once again, a VDI desktop on SAN or NAS, $1,000 in storage, $100 in servers and networking and so on. If you look at our close competitors, you're looking at somewhere between $400, $600, $700 per user. If you build VDI with an all-flash array, you can actually get a little bit lower because of some of the arrays have data optimization built in, like inline deduplication. But if you use us in a completely hyper-converged solution, we can provide you a very, very attractive price point and give you the excellent user experience that I just showed you. If you add in the extra, all of the other pieces of your VDI cost, we're looking at a total VDI cost per user of just above $400 per user. So once again, storage and USX, we're looking at about $85. Cost of the server about $100. Right. Add the broker and the hypervisor cost on top of that, another $150, and the Microsoft VDA license. So all in all, we're looking at about $425 completely loaded cost for persistent VDI. Very, very cheap, much cheaper than buying a new PC, buying a new laptop. So how does this stack up to some of our competitors, right? First, I want to dive into those recommended configurations using other server manufacturers that I was just talking about, right? So for each of the form factors, we've identified what our favorite platforms are. Doesn't mean you have to use these, but we really, really like these for particular reasons, right? So if we look at the high density servers, we like the Dell PowerEdge, we like the HP CS2500, we like the Supermicro Twin Pro. For the rack servers, you can see our recommendations for the Cisco, the Dell, the HP, the Lenovo bombs. And then for the blade servers, we like those models over there. And then in terms of compute and memory and so on, it is the same across all of those four. Where the differences are is really dependent on the form factor, whether we're using some full 400 gig SSDs or whether we're using a pair of 800 gig SSDs in the blades. Right? But using this configuration, we can provide you with a 25 terabyte all-flash effective capacity for your VDI virtual machines. So if you calculate that back for to your 500 desktop VDI deployment, that means that you can give each and every persistent desktop about 50 gigs of storage. So that is a lot of storage for a persistent VDI environment. All of this is with is configured using HA, so we can sustain one host failure. If you compare that to, say, an VMworld solution, there are some immediate differences you see, right? Just in terms of cost, the list price of an VMworld solution is much higher than what we can show you with the Supermicro, right? And there's some other interesting differences as well. First of all, compared to the VMworld, we can provide you with a lot more processing power. We're using faster CPUs. We're providing you more cores and so on. We're providing you more memory. Right? In terms of capacity, if you configure vSAN on a 4-node cluster with the ability to sustain one host failure, you're actually only getting about 7 terabytes of storage. With us, we're providing you 25 terabytes of all-flash storage. The VMworld storage is hybrid. It's using a little bit of flash and using spinning disks for the capacity. If you look at the density in terms of VDI, there's some dramatic differences as well. On the stateless side, VMworld specifications say, well, this will scale to about 250 desktops per appliance, looking at about $700 per stateless desktop. But if you look at the persistent desktops, because they only have 7 terabytes of storage available, you can only put 135 persistent desktops on an VMworld appliance. So look at what that does to the cost per desktop for a persistent desktop. We're looking at $1,350 per desktop. Whereas with us, you can put 500 persistent or stateless desktops on top of us, so we provide you a much cheaper cost per desktop. And the same if you compare us to a competitor like Nutanix, right? List price for a Nutanix is about 200 grand, right? Versus us, they will provide you about 16 terabytes of hybrid capacity versus 24 terabytes of all-flash capacity using us. So the cost per gigabyte and the cost per desktop is really related to that, is very similar, right? So lower cost in total, more capacity, and a much lower cost per gigabyte, and directly related as a lower cost per VDI desktop as well. Those are the slides that I prepared for you. We're at about 9:40 here in California. Let's see if there's any questions. Peggy, I assume you've been following the questions. Do you have a few teed up for me?
So I have been following the questions, and believe it or not, there are not any. Oh, here's one. So it says, hello, Mark. With USX version 2.0, is VMware distributed switches now supported?
Distributed switches are supported using USX 2.2 and vSphere. That is correct, yes.
Question, how does this apply to XenApp?
So XenApp, yeah, I didn't put it in the slides. So XenApp is a completely supported workload as well, of course. We've concentrated on VDI because we've done a lot of testing with XenDesktop. But very similar benefits apply to a XenApp environment as well. Typically, XenApp density is twice as high as a VDI density on a similar set of hardware. So if you would translate this configuration into a XenApp environment, we can sustain about 1,000 XenApp desktops. So you're running Windows Server 2012 in most cases with XenApp installed. Depending on your use case and the user profile, we have various options of configuring your Windows Server in terms of CPU and memory and so on. But across all of those XenApp instances, we will be able to give you somewhere between 800 and 1,200, once again, depending on the worker profile, XenApp desktops or XenApp application servers.
Okay, great. The next question, can you talk to cost comparisons with HP Moonshot?
Yeah, so HP Moonshot is really geared towards XenApp, right? It's in my opinion, it's not the most ideal platform for VDI because there is no virtualization. So each and every Moonshot cartridge will be a single VDI user. It's really a physical install of Windows 7 on that box. There are some use cases when with high-end graphics and so on for VDI, but in most cases, the cost per desktop is in the thousands of dollars. Where it does get interesting is with XenApp, where you're doing a physical install of Windows Server, you're installing XenApp on that. I've seen Citrix quoting somewhere between 40 and 50 users per cartridge, which gives you a hardware cost of about $40 or $50 per XenApp desktop. If you look at our price point, we will be able to pretty much match that. The benefits of our solution versus a Moonshot solution is a Moonshot cartridge is really, if you look up at it, is really a stateless instance, right? It is a single cartridge with a single hard disk. So once you have a hardware failure there, you're losing all of the information that is there. So you cannot use it for any kind of persistence, right? We provide you a completely persistent environment, meaning you can install XenApp either in a persistent way, or you can store the user data on us as well. With a Moonshot configuration, you would need some kind of external storage to store your user profile, store your user data. So that increases the cost of a Moonshot chassis or a Moonshot desktop.
Okay, great. The next question, will this support a multi-tenant model for use by cloud service providers?
Yeah, actually, we were working with a lot of cloud service providers using USX for their environment. As you can imagine, cloud service providers are very cost conscious. So anytime they have an opportunity to save money on their infrastructure, they'll take that with both hands, right? It means more margin to them, means more profit to them. We have some very interesting, for instance, Colt is using our software. Colt is a service provider in the UK. They're running somewhere between 10,000 and 20,000 desktops on top of our software to deliver very fast desktops to their customers, to their end users. And we have a few more examples in the US as well. In terms of multi-tenancy, yes, definitely. You can run multiple USX managers side by side, and you can provide multi-tenancy service that way.
Okay, thank you. For non-persistent, why not use IntelliCache version 2?
That's a good question. IntelliCache is definitely a very interesting technology, but it does read caching only, as if I remember correctly. The Atlantis software provides caching and optimization of both the read and write traffic. Plus, we're using inline deloop, inline compression, and so on to really make use of the caching layer as efficiently as possible. Of course, it's a very good example of technology that is trying to catch up with us. But because we are so focused on storage optimization, it is our game to always stay a few years ahead of where a generic vendor like Citrix can spend their efforts and so on.
Great. Do you recommend XenApp using provisioning services or machine creation services?
That is a loaded question, to be honest. There are a lot of people that like to use PVS for XenApp. There's a lot of knowledge on how to do this, how to scale this, and so on. From my perspective, I like MCS. I like using capabilities that are built into the hypervisor. As a technology, and as from an Atlantis perspective, we don't care. Our technology supports both. We provide the same benefits to both. It is up to the use case. It's up to what you are comfortable with as either the customer or the reseller or the partner to put in place. From a technology perspective, we support both.
Okay, great. This one has a typo, so bear with me as I'm trying to understand it. Can you use vSphere for or per XenServer for the hypervisor?
Yeah, so starting with USX 2.2, which will be generally available in about 2 months before the end of the month, we will support vSphere. So this is any vSphere version after, or including 5.1 and later. Or we're supporting XenServer 6.2 and 6.5. The feature parity, there's complete feature parity between the two platforms. So anything that you're used to doing on vSphere before with all the versions of USX, you now can do on XenServer as well.
Okay, looks like we've got one more. How does it compare with EMC vSpecs Blue?
Yeah, so I actually spent some time looking at the EMC vSpecs Blue announcements. What vSpecs Blue is an EvoRail appliance. Right? So they've taken the EvoRail spec. They're using some third-party server hardware, and they're basically building an EvoRail solution. And then they've tied in, they've integrated some of the EMC management and reporting capabilities. So it ties into some of the EMC management frameworks. They have some capabilities around things like call home and so on. So from a cost perspective, I think what I showed in the earlier slide where we're comparing against the generic EvoRail, I think you'll see very similar comparisons. They will probably be a little bit more expensive than what I showed on the screen because it has the EMC name. EMC customers will buy it. In terms of performance, we will blow the socks out of that, right? Our inline deduplication and so on. vSAN or EvoRail doesn't have any deduplication. Yes, it's using the SSDs as caching, but there's no optimization there. There's no data reduction there. So just to store your VDI images on EvoRail will always take a lot of SSD, will always take a lot of spinning servers, spinning disks. Our solution is completely all flash, so you get the inherent performance that is associated with all flash. All right, any more questions, guys? Feel free to ask. We have some more minutes over here.
It doesn't look like any more. Oh, here's one. So just to clarify, software installs to XenServer / vSphere.
Yeah, good question, Jana. Yes, so the way you provision our software, the way you install our software, the way you deploy our software for a VDI environment is as follows. First, you import our USX Manager VM. This is a virtual appliance. You import this to either vSphere or XenServer. You boot it up. You give it an IP address. This is all through an on-console wizard. And then you log into our web management UI. You tell us what servers we can use, what is the vCenter or what is the XenServer pool we can use. You tell us what storage we can use. And then from there on, you can start building volumes using those resources that you have identified to us to use. We can basically build volumes and provide optimized storage back to the hypervisors using the resources that you pointed to us. So very easy. We had an Atlantis event last week. I actually was on stage with one of the Citrix CTPs, and we actually did a live install of USX on XenServer. And we had everything up and running in about half an hour. And this was with a lot of talking, it was with a lot of explaining, it was with a lot of answering questions from the audience and so on. But really, time to desktop is very, very quick using our solution. Install the hypervisor, 10 to Xen, install USX, probably half an hour. Install XenDesktop with the new XenDesktop versions. You can probably get XenDesktop up and running within an hour as well. So you're really ready to provision or to run virtual desktops within a day. That's really my goal using the solution, is make it so easy for people to install, deploy, size, and so on, that you can start deploying, start worrying about really your desktop environment rather than your hardware and storage environment within a day.
Great, and it looks like we have one more question, which I will ask, but I wanted to let everyone know that I typed in the chat section that if you'd like a free trial, price quotes, or any other information, feel free to visit the www.atlantiscomputing.com, or you can send an email directly to sales@atlantiscomputing.com. So, Mark, one last question here is, any plan to support KVM?
Corey, good question. So KVM is definitely on our roadmap. It's not very significant right now in a VDI or a XenApp environment. I don't see an ask for KVM as a hypervisor. Why? Because XenDesktop doesn't support it yet. But if you look outside of the VDI workloads, if you look at things like OpenStack, yes, there is a big ask for support for KVM. So it's on our roadmap. We're working on it. You'll see more news coming around KVM support later this year. To add to what Peggy was saying, feel free to reach out to me on Twitter as well. My Twitter handle is my first name, last name, and then CA, because I live in California. So it's Mark Nijmeijer CA. I am on Twitter most of the day. So if you have any questions, feel free to reach out to there. There's a few more questions running in. Do we still have time to answer a few more, Peggy?
We sure do. So we'll run through these. What does performance look like with a tiered storage environment? Example, Flash plus SATA, SATA.
So I've done a lot of testing of both. What I typically see is that an all-flash environment performs just a tad bit better. Typically, you shy away from an all-flash environment because flash on a cost per gigabyte or a cost per VDI virtual machine is still too high. It is coming down in price rapidly, but using our inline duplication with our capability to basically amplify that space, it's a no-brainer to start using an all-flash environment. Right? Really, you get the performance of flash. You get our data layer to amplify that, so we really can give you the best of both worlds. If the log and VSI graph would look very similar in some sense because it still is an emulation. In most cases, you'll see that the user experience for an all-flash environment, when you really start pushing it, will be better than Flash plus SATA. If you think about it, the caching capability of Flash, at some point you're going to lose that, right? So at some point in time, you're going to run at SATA speed, so you'll see that in your user experience.
Okay, next question. Does the Atlantis appliance utilize the SRs that have previously been made available to the hypervisor?
Good question, good question. So yes, the way it works is that we put our data disks in the SRs that are being created from local storage in this hyper-converged example. So there will be a SR on each host that you will have formed out of your SSDs. Then we take the storage, we create virtual disks in those, we optimize, and then we create another SR that points back to our front end. So you create an NFS or an iSCSI SR that points to our volume VM. That's where we use it. That's where we run our NFS software or our iSCSI software. And then you put the VDI virtual machine in our storage repository. So once again, VDI in the NFS or iSCSI SR, and our data disks basically live in the local SSD SRs.
Okay, is there planned support for Hyper-V?
Yes, Hyper-V is a very strategic platform for us as well. Our engineering team is working hard on building similar performance characteristics and performance and management capabilities with Hyper-V. You will see news for that around summer, I think. That is the current plan to have Hyper-V done in USX.
Okay, Mark, it looks like that was the last question. So just wanted to, again, thank everybody for attending today. We have recorded this session, and it will be available. I'll send you all an email with the link either later today or tomorrow once we get it converted.
Excellent. Thanks, all. Thanks for attending. I'm very excited to be talking about this, and stay tuned for more news around this.
Great. Bye-bye.